So this video is actually a bit of a trick. I'm going to give you a question that in fact spans all three of Newton's laws. And you're going to have to try to solve this. And don't worry too much if you can't solve this. This is a very tricky question. But you should, because you're AP students, learn how to solve some of these tricky questions. And how to think about questions that you've maybe never seen before. So this is a very classic AP Physics problem. You have a table. The table's frictionless. And you have a block on this table. And the block weighs 10 kilograms. And the block is connected by a rope over a pulley that connects to the edge of the table and down to a 10 kilogram weight. Now the question is, assuming no friction and no complicating factors, how fast does this weight accelerate downward? And you can assume gravity to be 10 meters per second squared. So try to figure this out. If you can't, don't worry too much. But I think if you give a good solid effort and remember to apply Newton's third law to the rope, you should be good. So pause the video and take a second here. So let's look this through together. What are things we know? Objects in motion tend to stay in motion. Objects at rest tend to stay at rest. Which isn't super helpful here because gravity is a force, so we are going to see acceleration. We know F equals ma, force equals mass times acceleration. That should be more useful. And then we know that every action has an equal and opposite reaction. So let's start by applying that. This weight pulls down, and it pulls down on the rope, creating a force of tension. The rope, which creates an equal and opposite force, has a force of tension pulling up on the block. So the block is pulled up with force of tension. The rope is pulled down with force of tension. And because the rope is pulled down with force of tension, it goes around the pulley and pulls out on this block with force of tension. Still the same force of tension. And then this block pulls back on the rope with force of tension. So now the rope, we assume it's massless, because that would be a complicating factor, and we're assuming no complicating factors. So the rope's in equilibrium. The rope has two vectors, one pulling this way, one pulling this way. So there's no force on the rope. That's okay, because it's massless. It doesn't need a force to accelerate. So now what we're left with is the block down here has force of gravity pulling down on it and force of tension pulling up on it. So we can draw kind of a rudimentary diagram for it. And we know that its net force is those two added together. And then this one over here has a force of tension pulling over on it and nothing else. Now the rope can't stretch or contract. So however much this block here falls, this one has to go over by the same amount. And the same thing for acceleration, for velocity. Which means we know they have to have the same acceleration. If they have the same mass, which they do, and the same acceleration, then they must have the same force. So let's write out the forces here. For the one, force upper equals force of tension. Force lower equals force of gravity minus force of tension. And we know force upper has to equal force lower. So force of tension is force of gravity minus force of tension. Add it to both sides. Twice force of tension equals force of gravity. Now what's force of gravity? F equals ma. The acceleration of gravity is 10, and the mass of block is 10. That's 100 newtons. So we say 100 newtons equals twice the force of tension. Now we're getting there. Divide through by 2, the force of tension is 50 newtons. Pretty simple. One last step. Because we weren't asked to find force. What were we asked to find? Acceleration. So what's the acceleration? Well, F equals ma. So F over m equals a. It's a simple algebraic manipulation. So what do? We say force of 50 newtons over a 10 kilogram block is 5 meters per second squared. Meters per second squared is the right unit for acceleration. So we got it. That's how fast the block falls. If you followed along with that, you just understood one of the more important concepts in AP Physics. If you didn't, don't worry. You still have a chance to go over it some more. But you should start trying to take a look at that and making sure you get what's going on. So good luck.